Hello, I'm Franziska Brohmeyer from Vista in Munich and I'm presenting our resource-conserving irrigation service VariableRain. Vista is a value-adding company in the field of remote sensing based on solutions with almost 30 years of experience in translating state-of-the-art scientific methods into operational digital services for sustainable farming and food security. VariableRain provides site-specific irrigation recommendation based on information derived from satellite images and a simulation with Vista's crop growth model ProMed. ProMed is a fully spatial agricultural simulator owned by Vista and it is based on first-order physical and physiological principles and laws and simulates crop growth, yield, and all relevant land surface processes under different agricultural management alternatives. For the calibration of the model, we use information from satellite images. So as soon as the plants are sown, the model starts to run, driven by different meteorological parameters. At the beginning, the variability of the simulated scenarios is very broad, but with each satellite image, the simulation gets clearer and the yield forecast is becoming more and more accurate. In the end, it is very similar to the mapping of the combine harvester in terms of the patterns, but also in terms of the absolute quantity. To understand a bit better how the crop water demand is calculated, here you can see an example of the ProMed modeling procedure throughout the growing season of a crop. This is an example of a potato field in Germany, so the soil water content is shown on the lower graph, while plant leaf area development and rainfall are shown on the upper part. In Germany, potatoes are sown somewhere end of April, and at the beginning of the growing season there was not much rainfall. However, this did not result in strong reduction of soil water content since there was almost no biomass standing on the field. So only the upper 5 cm dried out a bit, but there was almost no reaction in the lower layers. Even low precipitation events supplied enough water to refill the upper layer. At the beginning of strong leaf development, more water is needed by the crops, and since no rainfall occurred, the fields were irrigated to ensure healthy development of the plants. The first irrigation resulted in refilling of the upper layers of the soil, and a second irrigation was applied a few days later since there was still no rainfall. After this, a phase with strong rainfall occurred, so the leaf area of the plants was developing very fast. There was a strong reaction in all three layers to even short times of drought due to the strongly growing biomass on the field. Since there was a lot of rainfall in that time, no irrigation was needed. Potatoes are very sensitive to water stress during flowering time, which was in the first half of July. Taking into account the weather forecast predicting a long time without rainfall, the fields were irrigated again to reduce the risk of yield loss. Due to a long period without rainfall, another irrigation became necessary. After 4 weeks of drought, a period with long and strong rainfall started, so that the crop stands still not entered the ripening phase. As soon as the plants reached ripening phase, the plants needed less water and the soil should be dry for harvesting, so there was no further irrigation recommended at the end of the season. Our new VariableRain platform combines all these information and makes the management of irrigation even smarter and easier for the farmer. For each field you can see the crop water demand on a 10 by 10 meter grid, showing also the average crop water demand in millimeter for the whole pivot and the first day of water stress. Beyond that, you can adjust the amount of water that should be applied for each sector based on individual circumstances, like for example power shutdowns. Based on additional forecast parameters like precipitation and temperature, the farmer can distribute the recommended amount of water for 1 week very easily. Once the irrigation plan for the upcoming week is ready, you can send a schedule to your irrigation system to be applied. This farm in Zambia gives one example of the successful implementation of variable rain. On that farm, the level of the water reservoir for irrigation was often very low during the last couple of years, so therefore the farmer faced a big challenge that he would have enough water for all pivots for the whole season. With variable rain, the crop water demand based on the actual development of biomass was simulated and used for weekly site-specific or sectoral irrigation advice. Vista's recommendation reduced the water use, resulting in sufficient irrigation water for all pivots for the whole season. And on top, the yield could even be increased by up to 25% in comparison with the year before. Summarizing the service variable rain, you need to mention that leaf area derived from satellite data is combined with complex crop growth modeling techniques in order to calculate the precise irrigation demand in millimeter for the upcoming week. In contrast to competing products, not only one environmental variable is used to determine the water requirement, but the crop is modeled within its environment and all factors are taken into account. The result is a demand-based irrigation map in millimeter for the coming week for wheat, barley, maize, rapeseed, triticale, sugar beet and potato. Thank you very much.